Okay, so up next we have 2017 number 2. Okay. So on number 2 here it says when a certain grocery store opens, it has 50 pounds of bananas on a display table. Customers remove bananas from the display table at a rate modeled by f of t equals 10 plus 0.8 t sine of t cubed over 100 for t between 0 and 12, where f of t is measured in pounds per hour and t is the number of hours after the store opened. After the store has been open for 3 hours, store employees add bananas to this display table at a rate modeled by g of t equals 3 plus 2.4 natural log t squared plus 2t for t between 3 and 12, where g of t is measured in pounds per hour and t is the number of hours after the store opened. All right, so because I'm given 2 equations on this one, the first thing that I would do, like I always do whenever I see equations given, I always put those into y1 and y2. So we're going to go ahead and put f of t into y1, so 10 plus 0.8 t sine fraction x cubed over 100. And then for y2, we'll put in the g function 3 plus 2.4 natural log x squared plus 2x. I got an extra parenthesis in there. Let's get rid of that. And I forgot an x. Of course I did. Okay. Oops. Okay. So everything looks good there. Yep. Okay. So I've got my 2 equations typed in my calculator. So let's go ahead and start working through the problem. Okay, again, because we have the trig, so make sure you are in radian mode if you haven't changed that already. Whenever you're using a calculator on calculus, make sure you are in radian mode. Okay? All right. Part A, how many pounds of banana are removed from the display table during the first 2 hours the store is open? So because it says removed, we're going to use the function that talks about removing. Customers remove bananas from the display table modeled by f of t. Now we did store f of t as y1 and we did store g of t as y2, so it might make sense, or it might be a good idea for you to label those as y1 and y2 on your paper here so we kind of know which ones we'll be using for which. Okay, so how many pounds of bananas removed? If I want to figure out how many total pounds of bananas are removed, I'm going to take the integral of my removal function. Okay, and in part A it says during the first 2 hours the store is open, so the first 2 hours would be from 0 to 2. Okay, so what we're going to do is we're going to go math 9, 0 to 2, and then the y1 function, and then dx. So 20.051. So in the first 2 hours, $20.051 pounds of bananas have been removed. Okay. You don't necessarily have to write the sentence there. It doesn't ask you for units. It doesn't ask for any kind of justification. But you know me, I like to do the most. So it just kind of helps tie it all together and helps answer the actual question. Okay. Part B. Find f prime of 7. So that's just the derivative of f at 7. This is just straight up calculator. Okay, you don't want to do this by hand or anything like that. So remember to calculate a derivative on your calculator. Press math 8, d over dx. The function here is f, which is y1. And I want to find the derivative at 7. So f prime of 7 is negative 8.119. So what does that mean, right? So we want to be able to apply this to the context of the problem and figure out what exactly does this mean. So F was already a rate. So F was the rate at which they were being removed, right? So this was in pounds per hour. Yep, pounds per hour. So this wouldn't be like pounds per hour again. Instead, what we're going to talk about is this derivative positive or negative, right? So because this derivative is negative, f is decreasing. Okay, so here's what I would say. I would say that after this, at t equals 7, the rate at which bananas are being removed is decreasing at a rate of 8.119 pounds per hour per hour. Okay, and let's see, just to kind of connect it to what we just found, it's negative, so it's a decreasing rate. And the reason we have per hour is because we're taking the derivative with respect to time. Okay, so f prime is the derivative of pounds per hour. So if I take the derivative again with respect to time, it would be pounds per hour per hour. All right. Remember, we always try and answer with our number, our units, so the pounds per hour, and at a specific time. All right, so make sure you always number, unit, and time. All right, that one's a little tricky, but I think you guys are capable of doing it. Part C, is the number of pounds of bananas on the display table increasing or decreasing at t equals 5? Give a reason for your answer. So on part C, part C, you can kind of look at it a couple different ways. I like to look at it from an integral perspective just because I think it might make a little more sense, but we can talk about different ways to look at this problem. So for part C, if we let A of t be the amount of bananas okay, so at any given time we can find the amount of bananas on the table. And so A of t would equal your initial amount of bananas on the table. And it says when a grocery store opens, it has 50 pounds of bananas on the table. So I'd put 50 plus, well, let's go minus, because they're going to be removed, right? So they're being removed at an integral of f. But, all right, so f is being the removal rate, and it's from 0 to 12. But then they're also being added back in, right? There's a stock boy going around and adding the bananas back on there, and they're being added back in using g of t. But notice how g of t starts with 3. Okay? So plus the integral from 3 to t of g of x dx. Okay? So that represents the amount of bananas at any given time t. And I can use this to find, am I increasing or decreasing at a particular time? All right? And if I'm trying to figure out if I'm increasing or decreasing, that's just a rate. And a rate is just a derivative. So I'm going to take the derivative of my amount equation. The derivative of 50 is 0. The derivative of this integral, the negative sign would stay, and all we're going to do is just plug in the bound. So f of t plus, and then on the next one, the derivative of an integral is just plug in the bound. Plug in your variable bound. So plus g of t. If I want to figure out, am I increasing or decreasing at t equals 5, then I can plug in 5. Okay, so let's see, y1 was f, so negative alpha trace y1 of 5 plus alpha y trace 2 of 5. So negative 2.263. So this is equal to negative 2.263. So because that rate's negative, are the bananas increasing or decreasing? So because that rate is negative, they are actually decreasing. So because a prime of 5, and that's going to equal negative f of 5 plus g of 5, because that's less than 0, the number of bananas is decreasing at t equal 5. Okay? All right. And how many pounds of bananas are on display table at time t equals 8? So this is part D here. Because we already wrote the equation for part C that represents the total amount of bananas, we can use that equation now. So the initial amount minus the rate at which the sum of the removals, so from 0 to t of f of x dx, plus the rate at which they're being added, so from 3 to t of g of x dx. All right, and I want to know how many are on there at time t equals 8. So I'm just going to plug in 8. So the integral from 0 to 8, and then the integral from 3 to 8. Okay, so type this in your calculator. 50 plus the integral from 0 to 8 of y1, because remember we let y1 be f, and it should be a minus in front of this integral because they're being removed. And then we're going to add on the rate at which they are being added back in, but remember that this interval will start at 3. So 23.347, and this would be pounds. Okay, at t equal 8. Again, we're not going to be allowed to, or we won't need our calculators for the AP exam, but again, the ideas in this problem are important, okay, and they could recycle some of these concepts on the AP exam this year. As far as points are concerned, part A would be worth 2 points, 1 point for your integral, 1 point for your answer. For part B, you would get 1 point for your value, 1 point for the meaning. In part C, if you consider f of 5 and g of 5, so that's kind of like this step here, you'd get your point, and then your answer with your reason would be your other point. In part D, you would get 2 points for your integral, all or nothing, and then 1 point for your answer. Okay, there's your 9-point breakdown for this one.